Okay, what are we looking at here? Right, we got pH along the bottom, PCO2 on the X, so we have sort of two X's because we have two lines. And then along the Y, we have alveolar ventilation. Read that as respiratory drive, right? How vigorously is the DRG moving air, okay? So we can see that for the PCO2 line, okay, when PCO2s get very low, in other words, below 30, our alveolar ventilation falls way down, right? In other words, if our PCO2 is really low, we breathe less. Okay, we've kind of already looked at that. Now, as our PCO2s increase, we see that our alveolar ventilation increases. So this is showing you that the DRG through the pH system is increasing respiratory rate as PCO2 increases. So it's the very same thing we talked about in pathology, right? Now, the pH line, you'll see, kind of follows the same sort of pattern. That as pH increases, well, here, let me move my thing so we can see this correctly. Look, this goes backwards. You see that? The pH line, high is over here, low is over here. So at a high pH, in other words, a basic pH, our minute ventilation is very low, right? Because essentially what we have here is a metabolic alkalosis, right? So we're breathing much less. As our pH increases, 7.4 is normal, right, for the body. So as we drop below 7.4 and head towards 7, we see that our pH dramatically increases. Now, the pH they are referring to here is the plasma pH, not the pH around the DRG. Remember that blood-brain barrier effect. Okay, so this is plasma pH, blood gas pH. Okay, so this is showing you what we talked about the other day, that as pH drops, minute ventilation increases. Now you'll see that this curve goes up and then back down on the other end. This is an important factor because when the pH of the plasma gets low enough, things start to break, right? We can tolerate high PCO2s much better than we can tolerate changes in pH. So below a pH of 7, the DRG isn't working right anymore. So it can't stimulate more respiratory drive because it's too sick to do so. Okay, that's this part over here. This curve is the death spiral, right? Because at that point, the DRG is too sick to do anything about it. Okay, so in terms of respiratory rate, PCO2 is the single of, well, let me rephrase that. PCO2 is the greatest effector of respiration, not oxygen. Even greater than PCO2 at the directly DRG is pH, is H+. Okay, so what happened? What happened?
Or she had a thing of water and it had a leak in it.
Oh, there's not really a fish involved, is there?
It's a golf ball. The golf ball's fine.
I'd have been worried if there was a fish.
I didn't either. I don't know, how did that happen?
Does it just spontaneously break?
I guess. I don't know. Okay. You were too focused on you.
It was magic that happened right in front of us. Didn't think it was that exciting. Okay, so of PCO2 and PO2, PCO2 is the greatest, okay, in terms of effect. Between pH and PCO2, it depends on where you are, right? If the pH is in the plasma, PCO2 will still have the greatest effect. If the pH, if you're talking about the pH at the DRG, that's going to have the strongest direct effect.